Unit 1, Day 4, Quadratic Parent Function and Transformations. The axis of symmetry is a line about which a figure is symmetric. Maximum minimum is the y-coordinate of the vertex of the quadratic function. We're going to be showing you how to find domain, range, end behavior, and transformations. Okay, so by now you should have learned where the h and k are in your equation. So this is the h and this is the k. The h describes the translations from left to right and right to left, and the k describes whether you're going up or down. So to find our vertex, we can go to positive 3 because the h is always a liar. So we can go to positive 3 and up 2. And that is where our vertex is. And since our a value is 1, that means that we're just going to use our over-up table and we're not going to modify it. So with our over-up table, we're going to go over 1, up 1, over 2, up 4, and over 3, up 9. So on this graph, I think we're only going to have room for 2. If even, it'd be somewhere around here. That's a good guesstimate. And then we can draw our lines up. And that is how you would graph that equation. Next, we have to find the axis of symmetry. These are the 5 things that you will usually be asked on the test. Axis of symmetry, as we defined earlier, is a line about which a figure is symmetric. So the axis of symmetry is always going to be the line of where your vertex is. So you find your vertex and it's always just going to be a dotted line right down there. And so here our axis of symmetry would be 3 because that's where it is on the x-axis. So next you will be asked to find the max or minimum and what that is. And so on this graph it's going to be minimum because from your vertex point everything is getting positive and going up, so you will eventually shade up. And so here what you would write was y equals 2 because that is where it is on the y-axis. You started recording again. Next you find your domain and range, and for these equations the domain is always the same. It's always going to be negative infinity comma positive infinity in parentheses, not brackets. And then for the range it's always going to be, for this equation it's 2 comma infinity. You start at 2 and go infinity, and you always have a bracket around the whole number and a parentheses around the infinity. Next you have to write the end behavior, and for this graph it would be as x approaches negative infinity, y approaches infinity. As x approaches infinity, y approaches infinity. Okay, for the next example, I've already made the graph, and our equation is y equals negative x squared minus 2. So we go down to negative 2, and since there's no x, we just go down there. And since a negative x squared, we have the reflection over the x-axis, and we go down 2. Those are our transformations. Very important. Next, I graphed it. So I put a point at negative 2, 0. We're going to find our axis of symmetry, which is just 0 because our vertex is 0, comma, negative 2. Okay, and then for this equation, it's a maximum because that's the highest it's ever going to get, and it's negative 2. For the domain is always the same, so it's negative infinity, comma, infinity. The range is going to be negative infinity, comma, negative 2. It always goes down from negative infinity up to negative 2. For our end behavior, it's going to be as x approaches negative infinity, y approaches negative infinity, and as x approaches infinity, y approaches negative infinity. And that's how you do this example. Okay, for the next equation, you are given a graph and you are asked to write the graph out into vertex form. And so to do that, we can just start with y equals, and then since it's vertex form, you know it's going to be the parentheses squared. So
we have x minus 2 because the h is a liar, and since it's 2 to the right, you have to say that it's 2 to the left because it's a liar. Then we go down 1, so minus 1, and it looks like it has a correlation of 1 because it goes over 1, down 1, over 1, down 1. But it reflects over the x-axis, which means that it's a negative 1. And so that's your answer. A common mistake that students make is accidentally writing the h value wrong. So right here, the negative 2 is our h value. So a common thing that students do is write plus 2, forgetting that h is a liar. But h is always a liar, so no matter if it's on the right, you have to say that it's on the left. If it's on the right, you have to say that it's on the left. A couple good things to remember: that the domain is always the same. It's always going to be negative infinity, comma, positive infinity in parentheses. And you always have to remember that h equals a big, fat liar. Do not trust h. It is never correct.
And a quick study tip to find the domain for every graph you do: domain is always the same.
Started recording again.